Hi guys, okay, this is the last video that I'm going to make, video number 4. In this video, I'm going to go over the two applications that are on the second page right here, and then the remaining questions. Now, I also removed some of the problems from the old notes, so if you downloaded this too early, then you have seen that there are 14 questions. I removed 2, so now there are only 12. Just letting you know, make sure you have the new version. I don't think anyone really probably downloaded the old one anyway, but just in case, you'll notice that there are 12 questions instead of 14. So just double check. Okay, so let's look at the two applications. Both applications are applications of the distance formula. First one talks about determining if 3 points are collinear. And collinear just means that the points lie on the same line. So here's an example visually real quick. In red, let's do red. So 3 points, let's say they're collinear. That means they're all in one line. I could draw a line, straight line through them, and it's going to connect all 3 points. As opposed to not collinear, if they're not collinear, then maybe one of the points lies off or something, right? So if I was to try to connect 2 dots, then I would miss the third one, right? Or if I connect one to the next one, it's going to look something like this. You're going to end up with a triangle. So how do I know if 3 points are collinear? Well, if they are collinear, just look at the distances. This first distance plus this second distance should add to the third distance. They should be all the same, right? These two shorter ones should equal they should sum to the third one. That's if they are collinear. Now, if they aren't collinear, if I take my short one plus my long one, that's going to be bigger than the overall one, right? It's going to be longer. And that's also something called the triangle inequality, essentially, which says that it's got to be the distance of any 2 points has got to be at least as long as the third one. But in general, if it's not collinear, they're going to be strictly longer, right? This is going to take you longer to go here and here than it is to go straight. So, well, how does application work? Well, in application, if you want to know if something's collinear, 3 points, then if I take 2 of the shorter distances, it should equal to the distance of the third one, the largest one. That's it. And now, what about the second application? Second application is for determining triangle types. So if you have 3 points in a triangle, P, Q, and R, you call it triangle P, Q, and R, and draw a little triangle to tell it's talking about a triangle. So I got P, Q, and R, right? P, Q, R. And then I want to know, okay, what kind of triangle do I have here? Well, again, you just use a distance formula to determine how long are each of those sides. And if 2 of them are the same, it's isosceles. If 3 of them are the same, it's equilateral. And if they're all different, it's scalene. Simple as that. So you just check the distances, and then, yeah, that's it. You just compare. So what distances are you comparing? Once more to reiterate, you do PQ, you do QR, and then you do PR. Those 3 distances. Now let's try the questions then. Starting with number 8 and 9. Number 8 and 9 are the collinear type of questions. So let's do them one at a time. Number 8 first. Okay, so here's number 8. Are these 3 points collinear? Okay, so this is going to be pretty mendokusai, we say, which is like, yeah, it's like a troublesome, but we gotta do it. We're going to check the distance between those 2, between these 2, and then between the first and the last. And then we'll compare the 2 small ones and the whichever one is the longest one. If the 2 smaller ones add to the length of the longest one, that means they are indeed collinear. So let's check. Okay. So let's do this one first. We'll call this first distance, we'll call that D1. Okay, and then we'll call this one D2. And this one D3. I'm just using this for convenience because I have 3 different distances to check, right? So D1. And I don't like the thickness of my pen. Sorry, give me a moment. Let me change this real quick. There we go. So D1, what is D1? Okay, we're just applying the distance formula. It's going to be x minus y squared plus y minus y squared, which is 1 squared plus 2 squared, or negative 2 squared, I guess. Same thing. Same thing as positive 2 squared, but it's okay. 1 plus 4, square root of that, right? Which is square root of 5. Okay, so first distance, square root of 5. Move on to the second distance in purple. What's d2? d2 should be the distance between 1, 2, and negative 1, negative 2. That's square root of 1 minus negative 1 squared plus 2 minus negative 2. You notice my use of parentheses to make sure I keep my negative straight and I don't mess something up. 1 minus negative 1 is 2. Square it. 2 minus negative 2 is 4. And then square it. It's going to give me 4 plus 16, which is the square root of 20. And the square root of 20, that's the square root of 4 times 5, right? Which means it's square root of 4 is 2, so that 2 can come out. I got 2 root 5. Okay, so 2 root 5 is d2. d1 was just a regular old root 5. This is kind of looking promising in terms of numbers. Maybe this might actually work. Let's see. What's the third one? Let's use a new color. Let's use black. Okay, d3. I'm sorry, guys. I'm sorry. I screwed you up. I realized I wrote d2 here. That was supposed to be d3. Sorry. d3 is square root of 0 minus negative 1 squared. That's the x values. And then 0 minus negative 2 squared. That's the y values. Which is the square root of negative 1 squared, or positive 1 squared actually, because it's 1 minus the negative. And then minus negative 2 is positive 2 squared. That's positive. So I've got, interesting. This is the square root of 1 plus 4 again, which is the square root of 5. Okay, so which ones are my shorter ones? Turns out this is one of the shorter ones. This is another one of the shorter ones. Shorter, we'll say shorter. Shorter. And then square root of 5 plus the square root of 5 is equal to 2 square root of 5s. So it is exactly equal, which means they're collinear. Yes, I have to look up how to spell collinear. I forget if it's one L or two L's, those two. Okay, sweet. That was awesome. That was exciting. Okay, number 9. We're going to check if these guys are collinear. Same exact process. Same exact process. So let's give us a little space here. Make that straight for me. Okay, this time let's do a little more color coordination. Right here, we'll call that D1, division 1, D2, division 2, and D3, division 3. Oh, it's not actually division, it's distance, okay? Okay, D1. Square root of the difference of the x values, negative 2 minus 3, quantity squared, plus the difference of the y values, 3 minus 1, quantity squared. Which is 2 minus 3 is negative 5. Negative 2 minus 3 is negative 5. Negative 5 squared. Plus 3 minus 1 is 2. 2 squared. So I've got square root of 25 plus 4, which is the square root of 29. Okay, it's not looking very promising because square root of 29 is a pretty ugly number to work with. Okay, D2. D2, where am I? Okay. Okay, 3 minus 2 squared plus 1 minus 1 quantity squared. Okay, that's easy. 3 minus 2 is 1. And 1 minus 1 is 0. So 1 squared plus 0 squared. Right? Which is just square root of 1. Or just 1. Okay, so D2 is 1. D1 was square root of 29. All right, see, I feel like it's unlikely that two are going to add up to the third one, but let's just check. D3. Oh, whoa. I said green D3. Zoom in a little more again. So D3 was this -2, 3, and 2, 1. So that's going to be -2 minus 2 squared plus 3 minus 1 squared. -2 minus 2 is -4 squared plus 3 minus 2 is 3 minus 1 is 2 squared. So I've got 4 squared is 16, and that's going to be 4. So it's going to be the square root of 20. Square root of 20. Okay, which one of these guys are smaller? Well, square root of 1 is 1. So that's the smallest one. And then this is square root of 20. This would be the next smallest one. So is 1 plus square root of 20, whoa, equal to square root of 29? And the answer is no, those are not equal. So that means not collinear. All right, sweet. On to the last 2 questions then. Identify the type of triangle. Now in practice, guys, identifying the type of triangle is going to look very similar to the process that we used for questions 8 and 9. I'll show you what I mean. Here's question number 11, right? Wait, what? 8 and 9. Oh, I just realized. I'm sorry, guys. The numbering is all off here. This is supposed to be question number 10. Okay. Here's what I'm going to do. I'm going to fix it in the notes. So by the time you guys see it, it should be okay. I'm going to call this question 10. This is question 11, okay? So question number 10 over here. This is question number 10. Oh, that was actually a pretty good fix. Okay, question number 10. Okay, I've got a triangle PQR. Well, I'm going to check first the segment PQ. How long is PQ? Then I'm going to check this segment. We'll call that QR. Since it's a line segment, sometimes we write a line over the top. And then PR. And the last question, I did the same thing, except I called this D1, D2, and D3. But the process is the same. So I'm going to check those. And then this time I'm going to check how many are equal and how many are not. And that's going to determine what kind of triangle I have. So we'll do this guy in red first. So PQ. Here's PQ, the distance of PQ. We'll call this the distance of PQ. What is that? It's -5 minus -1 squared plus 5 minus 4 squared. So that by the time you finish this classwork, you should be like, this should be so ingrained in you how to do these distance formulas that you're never going to forget it for the rest of your life. Plus you have homework after this, so it's going to be pounded in your head. -5 minus -1 is -4 quantity squared. 5 minus 4 is 1 quantity squared. So in the end, I have square root of 16 plus 1, which is the square root of 17. Okay, that's my first distance. Second distance is QR. We'll do that one in, let's use this new blue color. Ooh, that looks like a nice normal blue. This is the distance of QR as a segment. Okay, this is -1 minus -4 quantity squared, plus I've got 4 minus 1 quantity squared. That's -1 plus 4 is -3 squared. 4 minus 1 is 3 squared. So I've got the square root of 9 plus 9, or the square root of 18. Wow, interesting. You know, it's very close to square root of 17, but also at the same time, totally different. Okay, so that's QR. Now last one is PR, which we'll do in purple here. So the distance of this line segment PR is the same old thing all again. It's going to be -5 minus -4 quantity squared plus 5 minus 1 quantity squared. So -5 minus -4, that's going to be 5 plus 4, which is -1 squared. And 5 minus 1 is 4, quantity squared. Got the square root of that thing. So I end up with 1 plus 16, that whole thing square rooted. And then I have the square root of 17. Square root of 17. All right. So these guys are the same. And I have 2 of them that are the same. And what does that mean? Remember, 2 of the same means isosceles. Isosceles. Okay, I forgot how to spell it. Let me double check. Isosceles, just the C. ISOCELES. So I had it right the first time. Isosceles. Triangle. Yes. Ooh, last one question. One more question. Number 11. Oops. Okay, lasso this guy. Oh, I have a better idea. Just lasso this part. This is question number 11, guys, because I forgot to renumber when I edited the thing. What? Oh, sorry guys, hold on. Give me a moment. There we go. Okay, this is question number 11. And same deal as last time, yeah? This is going to be D1. I'm going to go back to calling it D1 again. D1, which is the distance between P and Q. D2, the distance between Q and R. And then, I feel like a new color. D3. Oh, this is not actually new. I think I used orange before. D3, the difference between, this is the difference between P and R. Okay, so one at a time. D1 first. This is the distance between P and Q. That's -4 minus 0, quantity squared, plus 8 minus 7, quantity squared. -4 minus 0 is just -4 squared. 8 minus 7 is 1 squared. So I've got that same number again, huh? 16 plus 1, square root of 17. Okay, D2. Let's do them all in a row. Equals. That's 0 minus -3 squared plus 7 minus 5 quantity squared, which is going to be square root of 3 squared plus 7 minus 5 is 2 plus 2 squared, which is the square root of 9 plus 4, or the square root of 13. Okay, third one, D3. It's the square root of 0 minus negative. Oh, I'm sorry, looking at the wrong number, guys. I should be looking at negative. This is P and R. So I'm looking at -4 minus -3 squared plus 8 minus 5 squared. -4 minus -3, that's -4 plus 3, which is a -1 squared, plus 8 minus 5 is 2, that's 2 squared, and the square root of all that. -1 squared is just 1, 2 squared is 4. So it's a square root of 5. Okay, so I've got square root of 5, I've got square root of 13, and square root of 17 as my 3 distances. They're all different, which makes this a scalene triangle, where all sides are different lengths. And with that, guys, we are finished with section 1.1. You'll notice we spent the vast majority of our time finding the distance between 2 points and applying that idea Make sure, for sure, you're able to do that. Guarantee you'll see one distance formula question at least on your first exam. And then make sure you also know how to do the midpoint. There's a good chance you have one of each of those in some form or another. It might come with some application, or it might come as just a normal question. All right, guys, have a great day. We are finished. Enjoy the rest of your week.